So welcome back. Let's start the next session. So my name is Yasutaka Kamei. I'm a professor at Kyushu University. So now many companies are interested in the adoption of the foundation models in their software development. Then, of course, they would face many challenges. So in this session, there are two talks about the challenges and the successful story in the context of the AI-aware in industrial settings. First talk is provided by Thomas Zimmermann, who is a principal researcher at Microsoft and SIGSOFT president. Yeah, and Tom, he will have a presentation from online. So please start, Tom, if you are ready.
Okay, can you hear me?
Yes, we can hear you.
Okay, perfect. And I'm hearing an echo, so I hear myself speaking. Okay. I still have the echo. I think it's gone now. Okay, thank you so much for having me. I'm here today to talk to you about trust for AI-powered tools for software developers. And this is based on a few studies that we did at Microsoft over the past few years. And I think we all know that AI-powered code generation tools, they introduce many new ways for developers to create software. A lot of people know GitHub Copilot, which is like a very powerful code generation tool in the Microsoft ecosystem, but there are many other similar tools which basically take a prompt within the IDE and create large pieces of source code that developers can use. And so what we've done over the past year, 2 years, is basically study how people are using AI-powered tools like Copilot. And some of our initial findings we published in a paper in ACMQ, where we basically did 3 initial case studies where we looked at the discussions in the discussion forum around Copilot. We did a case study and also did a survey to really find out how people are using tools like GitHub Copilot, how it changes the way we build software, and also how it affects the productivity. And so one theme that we were seeing as part of these studies was also that trust really is important for tool adoption and tool usage. And if you think about it, there's so many tools, but not all of the tools are being used in practice. And at the same time, tools are also continuing to emerge and evolve. Like from the traditional tools, which were very predictable, where people could rely on and kind of knew what we're getting into. We now have AI-assisted tools like GitHub Copilot or ChatGPT or any generative AI tool that you can think of, which sometimes have unpredictable outcomes. And so it's really important that we provide software developers with ways that they can build up appropriate trust in tools, because otherwise we can see suboptimal use of tools and also poor outcomes. And just to give you some examples, like I've mentioned, some people were really excited about AI-powered tools. Like in this quote, someone says, "Hey, I'm really trusting GitHub Copilot. I just hit Enter tab and let it do its thing. It saves me a lot of time and effort." So that's a really great case. But also other people thought that the idea of GitHub Copilot is cool, but also it's really dangerous, because if you just trust what Copilot does, is you stop reading the code that it generates, and then over time, you will end up with poor quality code that might have bugs or might have security vulnerabilities as well. And so here's like another example. So for someone who just showed what happens when they kept accepting the default suggestion on Copilot, they basically ended up with some not usable code. So all of this I'm showing you to give you an idea why it's important to think about trust when we talk about AI-powered tools for code generation, but not just for code generation. It's really for any development, software development task. And so there's this concept of over-reliance on AI, which basically occurs when the users of AI systems start accepting incorrect AI outputs, and this can lead to a lot of issues and errors. And so that's why it's really important to design AI systems for responsible trust. Within the software engineering community, there hasn't been too much work on what people see as trust in software tools. And so that's why we did a study on what factors influence developers' trust in software tools. And this is what I'm going to talk about a little bit today. And then I'm going to show you a few more studies that we did. So to find out what factors influence developers' trust in software tools, we did like a mixed methods study. So we started off with interviews with 18 practitioners at Microsoft, but also outside of Microsoft, because we wanted to get many different perspectives on AI-powered tools. And we basically interviewed a few practitioners to get an idea of how they define trust, but also discuss the concept of trust in tools and in the collaborations with other people. We then transcribed the interviews. So we had like a text document that we could annotate. We defined an initial V1 of a codebook and did a coding of the transcripts. As part of the coding, we also refined the initial codebook V1 to like a V2 version. And in the next step, we basically validated the codebook with a domain expert within Microsoft to make sure that the codes that we assigned are representative of the data that we were analyzing. And then we did a thematic analysis, and we identified 20 plus different factors which we saw developers talking about when they were discussing trust in software tools. And we did a thematic analysis and identified 5 dimensions of trust in software tools. And I'm now briefly going to talk about these 5 dimensions, which we also validated in a survey with 300 practitioners afterwards. So what are the 5 factors? So the 5 dimensions of factors. The 5 dimensions are personnel, interaction, control, system, and expectations. And so this is something which we abbreviated with PIXI. So we call this the PIXI framework. And for each of the different dimensions, we have like factors that belong to them. So for example, for personnel, we have intrinsic and extrinsic and social factors. For interaction, we basically have factors which are related to the engagement with the tool between software developers and the tool. For the control dimension, we basically have factors that explain how much control developers have over the tool and its usage. Then in system, we have properties of the AI-powered tool itself before it is actually being used by developers, but also during the actual usage of developers of a tool. And then we have another dimension, which is about expectations. So basically, what did developers expect about the tool? And so within each of these 5 dimensions, you have like a set of factors, which I've listed here on this slide. So for example, for the personal dimension, we have community, source reputation, key advantages, which I will talk about in a few moments. And I will not have time to go into all of the factors in all details. I'm actually only going to talk about the personal dimension today, but I encourage you to read the paper to get an idea of of the other 4 dimensions of the PIXI framework. So coming back to the personal dimension, so one factor that we identified as part of this personal dimension was around community. And so if there is an accessible community of developers that use the tool and share their experiences, that can influence the trust that software developers have about a tool and also about AI-powered tools. So for example, here are some quotes one developer was saying, that's probably recommended because with a community, that's how it's preferable if you're like leaning towards more into the more community-wide practices. So for them, it was really important to see that it is something which is adopted by the community and also used by the community where they share their experiences. And similar, like the other person was saying, like if there's no network of people using the tool, why should I be the one using it? Another factor that we found for the personal dimension was source reputation. And this is basically, which we defined as the reputation or familiarity with the individual, organization, or platform associated with the introduction of a tool. And so here's some example quotes was, if it's a person that I personally trust a lot, like for example, a coworker who I work closely with and have a lot of respect, then this carries a lot of weight for me to start using the tool and also to trust the tool. Or another developer said basically they get excited about Microsoft tools because they trust the Microsoft brand. And the third dimension, the third factor related to trust that we identified in the personal dimension was around benefits and advantages of using a tool. So it has to be very clear what developers gain from using a tool and also get some validation by other people. So for example, quotes that we saw in this related to this factor were basically seeing that like when they started using the tool, they saw that it was very powerful and it was very easy to use, and that was really great. Or another developer was talking about basically AI systems in self-driving cars, and they said it actually stopped the right car, and so that built up trust for them over time, that they can rely on the AI in the system. So how can you use the PIXI's framework to build up trust in your software systems? So you can think of each of these different factors as important properties of the software that you build, and then you can think of ways how you can have a positive impact on these factors. So for example, the source reputation factor, which we found to be really important for adoption of tools as well, in addition to trust, is like one way you can increase the trust in the tools that you build is to introduce it to the community via trusted sources, to have like a network of people who are using the tool and who share knowledge about using the tool. Similarly, for providing clear advantages and benefits of using a tool, if you can provide tool demos or comparisons of a tool, or like have like forums to showcase new tools. So for example, one thing which the GitHub Copilot team was doing is they had a discussion forum where people could show off cool things that we were doing with GitHub Copilot. And then also the community aspect. So that's really important, is to build a community around a tool, which helps people to build up trust in a tool and also make sure that this community is visible and accessible, which I think we're seeing very frequently on GitHub. So one question you're also asking is if we see differences between trust and traditional tools. and AI-assisted tools. And generally, we saw that the priorities were similar for both, like being consistent in the performance, meeting expectations was really important for both. Some of the interaction factors were slightly less important, again, for both. One thing that we saw in particularly important for AI-assisted tools was that like providing support to validate recommendations by the tools, the autonomy of people using the tool, and also the reputation of the people who build it was really important for AI-powered tools. We also ask about different types of tasks where people would trust tools like AI-powered tools more. So for example, we saw there's a fairly higher trust in AI-assisted co-completion tools and code generation tools. And that's probably because people had some experience with using GitHub Copilot, and they saw the capabilities of Copilot in practice. There was slightly less trust in AI-assisted debugging tools, and partly we believe that people just haven't seen debugging tools that use much of AI yet. So, but overall, like the differences between the different tasks weren't as big as we expected. So I now want to show another study that we did where we explored how we can actually design tools to facilitate trust in AI-powered code generation tools. And so this is a bit inspired by another model for trust, which is called the match model for responsible trust. And basically what this model introduces is the concept of trustworthiness queues, which is basically information within a system that can queue or contribute to a user's judgments. Then it also introduces trust affordances, which are basically properties of a system that are visible, that are basically displayed, and that engender trustworthiness queues. And then you have trust heuristics, which are rule of thumbs that a user can apply to any of his queues to come up with a judgment of trustworthiness. So based on this model, we defined 3 research questions. So one was like, what type of queues and affordances do developers need to build appropriate trust with AI code generation tools? Then the next question was, what challenges do developers face in the trust building process? And the third question was like how we can design the user experience to really support developers to build appropriate trust. And for this, we conducted 2 studies. Like the first study was a study where we did experience sampling and a debrief interview. And this is what I'm going to show mainly today. And the second study, we did a design probe where we basically came up with mock-ups of UX, user experience enhancements, and we showed them to developers and we asked them about feedback, how it would change their experience and how it would affect their trust and trust building process. So let me talk about the first study in a bit more detail. So basically we asked people to record or to collect significant moments of using GitHub Copilot. So basically to collect the experience of using GitHub Copilot via screenshots and short descriptions. And the way we collected these was actually very lightweight through like a Microsoft Teams chat where we prompted them with if they have any moment where they like appreciate what GitHub Copilot did, or where they were frustrated, or where they were just uncertain about the recommendations that Copilot provided. They should take a screenshot and give us some explanation. And we asked them to do this for, I think, a period of 1 or 2 weeks, and then we did a debrief interview. So we randomly sampled from 1,500 internal developers, 17 participants we ended up interviewing and collecting the data for. And I'm now going to share some of the results. So like one of the findings was that was really around the developer information needs that they have in building appropriate trust. So, and this was basically around helping developers to build up reasonable expectations of what the AI-powered tool can do, like its abilities, but also the risks that are being posed with respect to the tool. And so one quote by one of the participants was, the trust basically comes back to learning what Copilot is suited for versus what it is not suited for. Related to that, we also found out about what information developers want in particular with respect to how they can control and set the preference for the experience of using AI-powered tools. And this was like some of the dimensions we saw here was basically developers wanted to be able to control what the AI-powered system produces, when and also how the AI-powered system steps in. And also we wanted to know what context actually the AI-powered system was using. So for example, if you think back about GitHub Copilot, one interesting aspect of Copilot is it's using implicit context. So basically it looks at your code file and extracts relevant information, but it's not always clear to developers what is being used to make recommendations. And so basically it was important for people to stay the pilot and not become the co-pilot themselves. Another observation we had with respect to information needs is that was basically around the evaluation of recommendations by AI-powered tools. And in particular, in each instance, like people wanted to assess like how good a recommendation is and also why these have been made. And so we were thinking about different strategies to make sure that the code is actually correct. So just to summarize, like here the 3 information needs we basically identified. So one was around the expectations of AI abilities and risks. We found ways to control AI as a really important need of developers. And also we saw that people wanted to have feedback about the quality and the reasons why AI made certain suggestions. The second finding that we had was that also developers face several challenges in building appropriate trust, and they were in a way very related to the information needs that we identified. So basically we saw that there is, it's sometimes not easy to set proper expectations because often the initial experience of using a tool has a lot of bias on how people perceive a tool, or they might be biased based on experience of using similar tools. People were concerned that they could not control the AI. So for example, some people asked for features to disable Copilot for like 1 hour so that they could do more focused programming. And then also providing better support for being able to suggest, to evaluate the quality of recommendations. That was like another important ask of developers, because it's often really difficult to assess the quality of code recommendation by just looking at the source code, and it has a very high cognitive load. So what we did next is we did design probes combined with interviews, and for each of the three information needs and challenges that we identified, we basically came up with one mock-up of a design, of a user design that could help address this shortcoming in the IDE. So just to be clear, we didn't build these, we didn't implement these specific features. It was more like, it was like a mock-up in PowerPoint that we walked people through as part of an interview. I will not have time to go through all of this today. If you're interested in the design probe and interviews, I encourage you to read the paper as well. But I want to share some of the, I think, key design recommendations that we have for tool builders. It's basically empower your developers to build appropriate trust, appropriate expectations of what the tool can do, because that really is important for building and evolving trust. Then offer affordances and also guidance in how to customize the system in a way that's really helpful for developers, and provide signals that help to assess the quality of recommendations that are being made by the AI-powered tool. We did a third study related to trust, where we asked specifically about how online communities affect developers' trust in AI-powered tools. I'm pretty much out of time, so I will not show all of the details, but the three takeaways from this paper was that community has like a really big influence on trust. Like developers use online communities to learn about tools. Based on what they read in online communities, they form trust in tools, and basically through the shared experiences and discussions that they see in these online communities. There is like a huge opportunity for providing community signals to help developers evaluate code recommendations, or like any type of recommendation, really. So you could think of like providing back code quality indicators or discussions that are sourced from a community. And that's basically the third point, is embedding these community insights directly into this AI tool that can help you to enhance trust and also to provide better code safety and improve developer productivity. So to summarize, what I want you to take away from this talk today is, I want you to remember the PIXI framework for like 5 dimensions of trust factors that we identified as important for software tools, and in particular for AI-powered tools. I want you to remember the designer recommendations that we found for building appropriate expectations in software tools, providing customizations of your AI-powered tools, and also providing ways to help developers assess the quality of any recommendations that your tools make. And lastly, also the community study, like I want you to remember the community, like online communities, have a really big influence on software developers, but there's also like a huge potential on leveraging the online communities within your AI-powered tools. And if you think back about like Stack Overflow, I think is like one of the really powerful online communities. And there have been some efforts in putting back signals from Stack Overflow into IDEs, but there are many other ways you can think of providing community feedback back to the developer. And finally, all of this work has been done with amazing collaborators, and I want to thank them for the great discussions, the amazing insights, and I look forward to many more projects with them. And that's my talk.
Thank you, Tom. So we will have all questions after the talk. So
Okay.
thank